So in this video, we're going to be checking the z-axis alignment perpendicularity relative to the xy plane. You'll recall previously in the assembly process, you were required to determine the number of shims that would need to be installed either between the upper bearings and the x-axis carriage or between the lower bearings and the x-axis carriage. And that was dependent on the information provided on the inspection tags, which were applied to the gantry and to the x-axis carriage. The point of that was to get as close as possible to provide basically a starting point of shims needed to ensure really good z-axis alignment. With that being said, it's important to come back after you face your base plate to check that, to make sure that no additional shimming is needed, or you might want to try to extract as much performance as possible in terms of alignment. So you may want to play with your shim stacks to try to get it as perfect as it can be. But with that being said, what we recommend aiming for is no more than about 0.02 of perpendicularity error between the z-axis and the xy plane over 3 inches of z-axis travel. So we're going to go ahead and take that measurement on the machine here, and to do that, I need a couple of items. First is a block of known squareness. So I'm going to be using a 1-2-3 block. Very common tool in the shop. I'm going to be sweeping up and down on the 3-inch long edge. To do that, I'm going to be using one of our linear systems dial indicator setups. I've got the magnetic base attached to the side of the spindle cover, and I've got the tip of my indicator sensing on that surface. And I've got it zeroed out, so you can see it's reading right on 0. And all I'm going to do is jog it down roughly 3 inches, and I'm going to watch the indicator and see which direction it goes and the magnitude of the delta. So looking at the indicator, it looks like there's just about 1.5 thousandths of alignment error over a 3-inch distance. So that's really good. So, for this machine, I'm going to leave that alone. That's within kind of the 0.02 of what I would say is an acceptable alignment error. With that being said, some of you out there may want to try to dial this in as perfect as you can. And to do that, that's where you need to start playing with your shim stacks. Because my indicator tip was starting to sweep clockwise, what that's telling me is that my nod of the spindle is kind of pointed this way, which means that I would have too many shims between my upper bearings and my XZ carriage. So on this particular machine, I know that there's 3 shims, which equates to a little bit over 3 thousandths of shim stack between the upper bearings and the x-axis carriage. Each shim will theoretically equate to about 0.5 of delta on my indicator. So if I've got 1.5 thousandth right now and I remove a shim, I would expect to see about 1,000th of error. So I may, if I was to go and try to fine tune this better, I may go pull out 2 shims and see what I get there. Probably get a little bit closer to 0. But like I said, 1.5 thousandths is really good for this machine. So now if you're going to go ahead and start playing with the shim stacks, the most important thing is that when you install them, as we had iterated in the previous video, when you install them, you want to make sure you're applying firm pressure to the x-axis it's essentially pinch those shims in there when you install the bolt, so that you've got intimate contact between the x-axis carriage, the shims, and they're being pinched between the x-axis carriage and the bearings. That's really, really important. Similarly, if you need to add shims down at the bottom, you use the same type of approach where you are making sure that there's no air gap there at all and the shims are placed properly. That being said, if you guys have any questions about the process, feel free to reach out to us. Thanks.